10-1 beta, we're going to have you come back to that problem we showed you yesterday. Open book problem. Ready? You got 3 minutes. X equals sine t, y equals cosine or cosecant t, and you need the first derivative to see whether it's increasing or decreasing. You need the second derivative to talk about concavity. And you don't remember the derivatives of the trig functions, then turn back and look them up because the clock is moving. All right, sorry, that email took a little longer than I expected. You should be done. I mean, here's what you have to do. So is it increasing or decreasing? We got to take the derivative. Derivative of cosecant is negative cosecant cotangent. Derivative of sine is cosine. So I write it this way. I wrote negative cosecant as negative 1 over sine. I wrote cotangent as cosine over sine. And then I wrote that cosine as 1 over cosine. What's happening? They reduce. You get negative 1 over sine squared. At pi over 4, that's negative. We don't care about a value. You can stop there. It's negative, so the parent graph is decreasing. Yes? Second derivative. So right there, it's decreasing, so that eliminates 2 of the answers. For the concavity, I have to take the derivative of the first derivative. So I have to differentiate negative 1 over sine squared and divide that by dx, which is cosine t. So I took the cosine t and put it over here to the right and did the quotient rule to the numerator. And you can see the work. It takes you to a positive. The positive means it's concave up. So the issue was the first derivative is negative, so the function's decreasing. The second derivative is positive, so while it's decreasing, it's concave up. You need this review of the derivatives of trig functions. I don't know what to tell you. So, in the textbook, there's really nothing to go over on the PowerPoint, because here's where they take you to the textbook. This picture, which is on page 533. So you have this curve over here, and we want the length of the parametric curve. Well, we're going to do the same thing we did in section 7.4 that is on your assessment at the end of this week. And we're going to look at this as being a Pythagorean. So we're saying, okay, here's delta x, which is dx dt squared. Here's the height, delta y, dy dt squared. And we take the square root of the sum. And we're going to evaluate that from the limits, and that's going to be the length of the curve dt. Okay, so it's the same approach as you used in the length of function curves in 7.4. And you're going to use this, and what are you accountable for now? In 10.1, you're accountable for 2 things. The derivative of a parametric curve and the length of a parametric curve. God bless you. So I'm saying to you, here is 7.4. There's the length of a curve in function mode. That's what you're being assessed on at the end of the week. And 4, what we're doing here, that from the textbook. Like, contrast them. So we get down here to example 3. We want this. We want the length of this curve from 0 to pi over 2. So we have cosine cube t and sine cube t. So I go to the calculator, go to mode, I have cosine t So I only want from 0 to pi over 2. So I'm just going to draw that much of it. Okay? So you want the length of that. That's what you're being asked to do. So we get, I mean, if I went back here to window and said 2 pi, that's the curve, but you only want the curve in the first quadrant. Does that make sense? So how do we do this? Well, we got to find the derivative of x and square it. So the derivative of cosine cubed, use the power rule. It's 3 cosine squared d mu, because you have mu cubed, yes? You want the derivative with respect to x of mu cubed. So that would be 3 mu squared d mu dx. And that's how we're getting 3 cosine squared times a negative sine. And that whole thing is squared. Well, this is multiplication. You can distribute an exponent over multiplication. And you would get 3 squared is 9. Cosine squared raised to the second power is cosine of the fourth. Negative sine t squared would be positive sine squared t. We go here, sine cubed, same thing. It takes you to 9 sine to the fourth cosine squared. So the sum of those two would be this plus this under the root sign. Except now you have to look for something. You look for the greatest common factor. The greatest common factor on both sides of this addition sign is 9 cosine squared sine squared. Take that out. What does that leave you with? Cosine squared plus sine squared, which is the identity. That's 1. So you just have the square root of this, which would be 3 times the absolute value of cosine t sine t. From 0 to pi over 2, took the 3 out. Ready? I have to anti-differentiate this. So what's the issue? Well, I want to anti-differentiate sine, because cosine is the derivative sign. So if I say sine is my mu, then cosine is part of my d mu. So sine gets anti-differentiated, gives you sine squared over 2. Bring that 2 out front with the 3. 3 halves from 0 to pi over 2. Pi over 2. The sine is the y value. At pi over 2, that's a 1. 1 squared. 0 is a 0. Check that. You're not positive it's a 0. If that had been cosine squared, that wouldn't be a 0. You're subtracting. And you get 3 halves. Okay? 3 halves is from 0 to pi over 2. The graph was symmetric, so if you wanted all of the area, in all 4 quadrants, you multiply it by 4. So the length of the curve from 0 to 2 pi would be 6. All right. So we're going to leave that up there. That's your model. And you're going to go to problem 29. So ready? Differentiate x. Derivative of cosine's negative sign. On the right side of the addition sign, you have the product rule, though. It's 8t times sine t. Derivative of the first term is 8 times the second term plus the first term times the derivative of the second term. Those two terms add to 0, and you're left with 8t cosine t. Then you can follow the right column. You have to square that. Well, you distribute an exponent over multiplication. So you get 64t squared cosine squared t. You see what you get on the right. So the greatest common factor is 64t squared times Pythagorean identity. So the square root of 64t squared is 8t. You're going to anti-differentiate that. Power rule in reverse. From 0 to pi over 2. So pi over 2 squared gives you pi squared over 4. The 4's reduce. The 0 gives you a 0, and you end up with pi squared. All right. So, you're just following the algorithm, and you're getting some practice with doing some anti-differentiation. So, the calendar, ready? You are taking the test on chapter 7 at the end of this week, and we are starting 10-2, the alpha lesson, on the days that you are not being tested. So the test is on displacement, area between curves, volumes, and lengths of curves. Okay? If you're in the building, we have AP classroom, we have AP lunch today. If you're at home, you are dismissed to do the exit ticket.